Okay, welcome back. I wanted to do a little update of how this custom Marshall 1987 50-watt model amplifier is going along. The big thing I'm doing right now is working on the hardware modifications that are necessary to build the amplifier the way that I want it. So what you're seeing in front of you is the 3D model. That might seem completely pointless, but what I want to make sure is that the physical modifications that I'm making will actually work. I have built amplifiers before where something I thought would work didn't work, and I had to kind of go in and cut things out, and it didn't look good in the end in order to make things really work. So I'm trying to avoid that situation because I want this to be an heirloom quality forever amplifier that I'll never want to sell. So one of the advantages of the 3D model is that I was able to find some issues with this amplifier. Now, if you look over here, you can see a weird line that is kind of projecting through the chassis. And really, it's right in line with the chassis. And what that is the turret board. When I modeled this turret board up, this is kind of clunky to zoom in and out of sometimes, but when I modeled the turret board up, I did a pretty good job of getting all the holes for the chassis lined up with the holes in the turret board, and it turned out that there's this small interference on one side. So I went and I got the real turret board and the real chassis, and indeed it does not quite fit. So what I'm going to need to do is, before I start building this turret board, is just to take and cut about 1/8 of an inch off of the edge here with the table saw. And then that will remedy that problem. Now, in my video where I was covering the fancy switches that I bought, here we see the kind of traditional plexi style switch with the 2 blades. And in some previous builds, I have used these large 15 amp switches, and they're really nice, they're really robust. But if you look closely on the model here, these lugs are actually protruding into the power transformer. Again, I went and I actually installed the switch and the power transformer into the chassis, and there indeed is an interference. Now, there's a possibility that I could, grind that down and maybe drill a different hole for the wires. But, I'd just go with the classic plexi switches. I'm sure if there was something in between these, it would work pretty well, but these are the switches that I had access to that were more than just kind of a normal switch like this. So I did think, okay, well, what if I was to put a nut on the other side and kind of lift this up from the chassis a little bit? But even with that, I still had that interference. So, about 3 of these switches, unfortunately 2 of them I won't be able to use on this build. But here you can see some of the rest of the modifications. I'm going to go through those one by one. So we're going to start with the front panel. One of the options on the front panel is where the traditional presence control is. This is where some people will sometimes put a master volume. And I think that the master volume is going to be something I'm going to adjust more than the presence control. I usually keep the presence right up on 10 or 11, however you want to look at it. And so I think what I'm going to do is put the master volume here and then put the presence back here, which is kind of interesting because the presence actually feeds in from the tap on the output transformer. So it kind of does this and then crosses over here and comes over to this part anyway. So I had some, when I was repairing my previous amplifier of the same model to get it ready to sell, actually wired that wrong. and it took a while to kind of figure out this circuit. It's kind of half over here and half over here. So just keeping it over here, that's going to make some changes to the electrical layout, but it might give it a little bit more signal integrity because that's not going to cross this kind of high signal area over around the phase inverter. So just in case the master volume is going to end up back here, I did throw in a dual potentiometer there, and it looks like the dual potentiometers are going to fit. There's not going to be interference issues with the turret board or anything like that. So another thing that I was wondering about, I kind of questioned during my last video if there was a bright cap on this model or not. The 1987X that's currently produced by Marshall and a lot of the reproduction amplifiers do have a bright cap. The amp that I had repaired, for some reason I had taken that out. I was following a different layout or something, and I think I actually found the capacitor that I pulled off of. I mentioned in that video that I had built it incorrectly, that I spaced the turret board for 1.5 inches, and so it basically took up the entire chassis. And when I redid it, I followed a different layout, which means the bright cap came out. So I may actually install that bright cap back in there. The question is that going to help me sell it or not? Because it might not sound quite as loud with the bright cap out. So I don't know. Maybe that's something I could mention to the sellers. I could put it back in, or I could leave it out. But anyway, so I'm really a fan of options, having options to do things, which is one of the reasons I bought the transformer that had the JTM45 windings, and also the 50 volt plexi walk, the solid state rectified plexi windings, 1987. And so one of the things I thought would be nice would be to have a push-pull switch, and so that's what I modeled up here, is a switch potentiometer, so that when you pull it out, the bright cap is engaged, so you can switch between that. I had thought about just putting a switch on the front panel, but if I can keep the aesthetic correct and just have a push-pull pot there, then I think that's an ideal solution. Again, one of the modifications we're going to be doing, which is not modeled up here, is on the input jacks. I'm going to make those the Vox style wiring, because the Marshall wiring, number one, it takes a lot of space on the board here because you have your mixer resistors here, and then you have these unshielded wires that go to resistors, which then go through unshielded wires down to your sockets, and there's just a lot of noise that could be picked up there. Whereas with the Vox wiring, your mixer resistors are here on the sockets, and you can run some shielded wire straight back to your inputs on that first tube, and it makes a much more cleaner setup. So looking at the top of the chassis, you can see here, right in the back by the tubes, there's a little, looks like a button coming up. That is actually a potentiometer that will be used for setting the bias. So traditionally, your bias potentiometer would be in this area, and one of the things I did in my previous build where I talked about that repair was that I had that external bias pot. And in conjunction with some of the other mods that I'll show you, that'll make it so that you could bias the amplifier without even removing it from the head cabinet. Well, maybe removing it a little bit, but without having to tip it over and try to operate it like that. So next thing we're going to talk about is, I mentioned probably putting on the back panel, would probably be putting the presence in that location. Let me jump back to this potentiometer. I kind of picked up from a junk bin a cap that goes on the potentiometer, and as you tighten it, it locks the potentiometer. And so I located that just the other day, tested it out, and it works pretty good. So I might cut a screwdriver slot in this pot so that I can adjust it with the screwdriver and then lock it in place so that it can't get bumped or anything like that. So that's going to be a pretty useful feature. So again, presence knob is likely going to come back here, which is one of the modifications, adding this knob on the back panel. And then if you notice here, there's a lot of weird stuff going on. So in the middle, you see one of those heavy-duty switches that I was talking about. This is going to be a pentode triode switch. In this layout, this is ideally located right between the power tubes so that I can switch the plate voltage and the screen, the grid 2 voltage, in such a way that these tubes can either operate in their full 50-watt output power, or in pentode triode mode, it's going to run less efficiently, which is actually going to run at 40% or 20 watts. So sometimes you see people that will build a plexi amplifier with 6V6s rather than 6L6s or EL34s to try to get to that 20 watt value. Well, you can simply just add in a switch and you can get there yourself. So with the master volume and that pentode triode switch, you really have a lot of options as far as the kind of output that you can push, and you can kind of adjust it according to your needs, whether you need a large venue that you're trying to fill or a small bedroom. So and then you notice these kind of goofy looking things here. I have 6 of them here, and I'm not really sure how many of those I'm going to use, but these are tip jacks. And what you would do is you would take, and actually let me enable this here. I modeled this up just to make sure the spacing was right. There we go. Just show these here. What these are for is so you can take multimeter leads, plug them directly into the amplifier, and it will give you test points outside the amplifier. I mentioned that we'd be able to, with some of these modifications, here we'd be able to adjust the bias, but here we could view the effects of those adjustments so it could get dialed in just right. So I had to make sure that I had a good plan for spacing. It looks like these, I think there's about 3/4 inches between each other and about 3/4 inches between here and the center point of the switch. And it looks like that's going to give me a good amount of room. So what are these test points going to be? Well, what I definitely want to do is have 4 of these test points, one each going to a 1 ohm resistor that's going to be in series with the plate. So in between the output transformer and the plate connection on the tube. And this is going to give me, it's going to translate millivolts of, or milliamps of plate current into millivolts that can be read by the meter. And I'm also going to be able to, so I'm going to be reading it on both sides. On the build that I had just repaired, and I only had it on one side, and it was quite a useful feature, but I always knew that it was not exactly right. There are some things you can do. Maybe if one tube's pulling a little more current than the other because they're not quite matched, you could swap that. If the output transformers windings aren't quite matched very well, you could swap those and match them up a little bit, but it's not going to do a lot. You can at least know that you're not going to burn up either of the tubes by knowing what that value is. And then, so there's the plate resistant measurement. There's also possibly, I could put the the center tap value. And that would give me the ability to read resistance between on the output transformer windings. If we know the current going through it and the resistance of the winding, that's another way that we could use to bias the amplifier. And then perhaps another one would be ground. And then as you measure from either of these points to the ground, that will give you the plate voltage. So if you have plate voltage, plate current, you can figure out how much DC dissipation you are using on your amplifier, so you can get it biased in whatever range you want. So let's see. I think I've covered everything. So those are the modifications that I've been working on. Unfortunately, it's taken me a lot longer to do this than I wanted to. And the next step is to go and I need to nail down where all these pins are going to go. So I have a little bit of kind of mechanical design to do. I've got kind of a layout that I've thought about. You can see I have some of the turrets laid out here to where I think they might need to go, but that could easily be adjusted. So I've got a 1-to-1 scale of this that I printed out, and I've laid my components over it. And the next step would be to try it out on the board without doing any soldering, just kind of dry fit the turrets, dry fit the components onto the turrets, make sure that it all makes sense, both spacing wise and where everything goes. And then that'll be the next step. So I need to figure out the electrical design, need to figure out the electrical design, do all the layout for the wiring, and then it'll be the next step where I can show what that has done. So there it is. That's the mechanical design for the custom reproduction of the Marshall 1987. Again, it's going to have some modifications, but those modifications aren't going to be able to be seen through the front panel. But along the back panel, you'll be able to see that there's certainly some funny stuff back here, but it's going to certainly add to the functionality of the amplifier. Unfortunately, there were some things I couldn't do, like use these big switches, but if this has worked good for that long, and then the question is, well, that must be why Valvestorm, who I bought these parts from, doesn't include this as part of the switches for their Plexi kit. That's probably why they use these with the terminals on the top rather than poking out the back. So sometimes you try to re-engineer things and you figure out why they engineered them the way they did in the first place. So I remembered the one other thing that I wanted to talk about, and that was the input jacks themselves. I tried really hard to try to find some way with these switching jacks where you could mix the channels together by maybe plugging it in halfway here, and if you only plugged in halfway, it would go to just the one channel, and if you plugged in the full way, it will go to both channels. That's something sometimes you'll use in like a guitar pedal, where if you don't have anything on where you plug it in the input, then your stereo jack, part of that's going to short to the ground, and then that's going to give you a path for your battery voltage. So if you don't have it plugged in, your battery's not going to wear down. Sometimes that's something that's used, but in this amp, it just wasn't going to work out. I took a couple days trying to figure that out, and it's just not really going to work out. So I'm going to have to rely on an external jumper, or perhaps I'll build a box and just run some leads down here so that we can run both of these channels. So there was a fancy jumper on eBay that was like $25 that would jump this using George L cables, and I might give that a shot. But anyway, that's it for the mechanical design, and now it's time to start drawing up layouts and translating that to schematics, and that's where we'll pick up next time. Thanks for watching. And I do want to say I certainly appreciate those of you who are subscribing to my channel. I don't really have aspirations of making a ton of money or anything really from YouTube. This is just things that I'm interested, that I'm posting in case you're interested in it. And when you subscribe, it kind of helps me know that you're interested and makes me think, man, I need to get back to that project. So that's what kind of got me back on track here. And I'll keep on pushing to get this done. So thank you very much. So after finding out my switches aren't going to fit, I really want to try to find something that works. And so I went on the Mojotone website and found this particular switch. It's not a DP-DT like the super heavy duty switch that I found that does something like 15 amps. And I went to the manufacturer's website, and it really looks like this is going to fit. I downloaded a 3D model from the manufacturer's website. I mean, you can clearly see the part number and the manufacturer there. And downloaded a 3D model, imported it into my amplifier, and it does give me quite a bit more room, and that's even with the larger lugs. This one has smaller lugs instead of the quick disconnect lugs, and so it's going to even fit any better. So I'm going to buy a couple of these and see if they'll fit in the amp, because I definitely like those better than the standard Plexi. I'm just going to have to do a quick spec check to make sure that they do equal to or greater, have a greater current capacity or equal to the original Plexi switches. So quick search on the Mouser website, and I've located the 9103D datasheet. Looks like it is a 6 amp switch, which also seems to match the specs for the original Carling blade style Plexi toggle switches. So it's going to be a good fit. I'm going to order a couple of those and see, hopefully that'll kind of give me what I'm looking for here. Also noticed as I was scrolling down this statement, this switch is great for applications with tight space restrictions. I wouldn't say that this is really a tight space restriction. It's just that the original switch I bought was so huge. Just a little bit about this little lock knob that I found for the potentiometer. I pulled this off of some sort of a junk thing that I bought from a surplus sale. And it originally was on a slotted potentiometer you could adjust with a screwdriver. Shouldn't be too hard to create that slot. But as you can see, this the hole here doesn't fit over the shaft. And it's got a little bit of a taper on the inside with the same threading as the potentiometer. So as you go ahead and tighten that down, it's going to lock that shaft in place. Now, one thing I didn't realize, I guess kind of naively, was that as you rotate this, it also, and you're tightening that down, it also turns the potentiometer. So what you have to do is actually put your screw in there and then turn it. I think when the original amplifier I used this in, I found out that the bias was set way high, and that's because I set the bias and then I put this lock thing on, and I had actually increased the bias in doing so. So anyway, that's a pretty cool thing. I've never seen one of these on sale before. It looks like it has a hex on here, so you could really tighten it down with like a wrench as you're holding it in place with a screwdriver. But kind of a pretty cool thing that'll make good use. I'll make good use of in this amp. I got a couple of parts in, as you can see here, from Mojotone, and I'm just going to kind of show those to you. So first of all, we got the push-pull pots, which would be used for the bright switch. And the thing I thought that goes in and out maybe a little bit too easily, but I'm sure it's going to be fine. So, and if I happen to like that bright switch mod, one of the things that I realized was with the amp that I'm replacing and I'm hoping to sell, to kind of help offset the cost of this amp I'm currently building is that it doesn't have a bright switch in it. Maybe that's the reason I never really, liked it as much as I thought I would, is because it's missing the bright switch. So I found the original cap that I had, actually the first time I built it, when I built it wrong, with the wrong turret board spacing, if you remember that portion of it. It actually had a bright cap then, and then I reworked it and took the bright cap off. So I found the original bright cap that I had used previously, and I'm sure it'll fit this pot just perfectly. So I might install one of these. So I did go ahead and order 2 of those. So this is in, so that's one more part I don't have to try to find. And then the other part that came in was these smaller switches. Now these are bigger than the Carling switches, and it's a double throw switch, but just I get confused by this single pole double throw stuff. It never really makes sense the way that you think it does. But anyhow, that's a switch, and if we compare it with the other, you can see there's quite a big difference in size. So whereas I knew this one wouldn't fit, this one looked like it would in the model, so I had purchased it and actually have installed one here. I don't know if the lighting's good enough to see that, but that's going to clear that transformer. So those will be really great to have in there. Have a little more of a high quality switch, and I just like the square ones more. So this kind of concludes the mechanical design portion of this build as far as major modifications to the chassis. There may be some small things as far as maybe some tag strips down here, 3-position tag strips for things like 1-ohm resistors. We'll be using the biasing circuit, maybe some screen resistors. We'll have to see how that all works out. As far as laying out the pentode triode switch and things like that. But those aren't really major changes, so we'll deal with those as they come. But now it's on to the electrical design. So that'll be the next video, is working out what to do there.